Hello, my sweet students. In this video, I'm going to be sharing with you some of my best tips and tricks for solving physics problems, particularly in this unit on motion and kinematics, but we're going to be using this same sort of format and process throughout the entire year. So let's dive in. At this point in the unit, we have talked about all these different quantities, displacements and times and velocities and accelerations, and we have these 5 different formulas that are available to us as we are solving these problems. And it can get a little bit overwhelming to try to figure out, okay, what formula am I using? What is the information that's given to me? How do I make sense of all of this? So I want to share with you the process that I use to solve a physics problem. You guess for these problems, but not like taking a stab in the dark, right? You follow the guess method, all right? So GUESS is an acronym. G stands for givens. So you start by combing through your problem and identifying what is all the information that is given to you in this problem. U stands for unknown. What is that desired quantity that we are trying to solve for? And in both of those, givens and unknowns, we definitely want to be sure to indicate the variables that go with each of those quantities. So don't just write, velocity, write V equals so that you can keep track of that. All right. So you've got your givens, you've got your unknown. The next thing that you do is you look for an equation that relates all those variables to each other to allow you to solve for that unknown. You also want to make sure as you're going through that that your equation makes sense for the scenario, all right? So if you have an object that's accelerating, you want to use one of your acceleration formulas. If you've got an object moving at a constant velocity, we'll use our constant velocity formula, all right? The next S is kind of like a 2-in-1. It's sub and solve, okay? So substitute your values that you identified into the formula and solve for your desired quantity, your unknown. Right? And then at the very end, the last S stands for sense check, where we're checking to make sure, like, does our answer make sense? Does it seem reasonable to us? Did we determine that our car is traveling at 10,000 miles per hour? Because that seems a little bit weird. Also, though, would be weird if it were moving at a freeway speed of like 0.1 inches per second, right? Like that would also be a strange answer. So we just do a little reality check to make sure that everything kind of seems reasonable. All right, so let's walk through a sample problem together. So we got a manic puppy here. It's just chilling, hanging out, but then there is a dog treat on the other side of the room, and this puppy likes treats, all right? So it accelerates at the steady rate, and it goes 12 meters in the course of 5 seconds and gets that treat. And we want to figure out how fast the puppy was moving by the time it reached the treat, all right? So first step in our method is G. G stands for givens. So I want to figure out what is the given information. Comb through that problem statement to see what information that I have. And numbers are often a really good place to start. So if I look at this, I see this number of 12 meters. Since that's measured in meters, that's telling me a displacement. So this indicates the displacement of the puppy while it's running across the room. I also see this number of 5 seconds. That represents a time. I know for sure because it's measured in seconds and time is measured in seconds. All right. So I have those 2 pieces of information. There's actually one more piece of information, one more number that's given to me, even though I don't see it in numerical form up here. Turn to your group and try to figure out what is the 3rd piece of information that we have here. All right. The 3rd thing that we have is the phrase starts at rest, all right? If you are starting at rest, it means that at the beginning of its journey, the puppy isn't moving at all, which means that it's starting off with an initial velocity of 0. So that is our 3rd piece of information that we have here. And as a little tip for you, anytime we're solving an acceleration problem specifically, we always have to have at least 3 pieces of information given to us in order to solve for a 4th piece of information. All right, that's not the case for constant velocity. Constant velocity, you can do it with two givens, but for acceleration problems, we need at least 3. All right, so there are our 3. Now let's move on to our unknown. What are we trying to solve for in this problem? So I see that the question is asking me how fast is the puppy moving, and that phrase how fast means velocity. So I'm trying to solve for the velocity of the puppy when it reaches the treat, all right? So that means that that's at the end of its journey. I'm solving for final velocity in this situation, all right? So those are my 4 4 pieces of information here, 3 given to me, 1 unknown that I'm trying to solve for. All right, now I'm ready to identify an equation to use. Now, first thing that I'm going to do is think about this scenario and what equations would be reasonable to use in this scenario. All right, so in this case, because we have a puppy that is accelerating, not moving at a constant velocity, I can pretty well rule out my constant velocity equation. I'm not interested in that one. I want to use one of my acceleration equations instead. So I look at my list that I generated in the first 2 parts. I know displacement, I know time, I know initial velocity, and I'm trying to solve for final velocity. So what I need to do is look at my acceleration equations and look for a formula that has all 4 of those variables, d, t, vi, and vf. Only one of those formulas has all 4 of those variables. Look over it and discuss with your group which equation do we want to use for this problem. All right, so looking at those 4 variables, looking for an equation that relates all 4 of those variables together, the equation that I found is the very first one. It has displacement, which I know. It has initial velocity, which I know. It has final velocity, which I'm trying to solve for, and it has time, which I know. All right, all the other equations all have acceleration in them. And while I know that the puppy accelerates, I don't know what the value of that acceleration is, so I can't plug anything in there, and I can't use any of those to solve this problem. Note, please, that even though we are solving for final velocity, that doesn't mean that we are using one of the equations that has VF equals some other expression in there, all right? It's totally okay for me to solve for final velocity using this first equation, even though currently displacement is the variable that's isolated on the left side of the equation. That's no big deal. It just means we're going to need to use a little bit of algebra to solve for VF from this equation. But this is the equation that we need to use. We cannot use one of the other ones. So focus on the combination of variables and not what variable is isolated in the formula. All right, so we're going to use that first equation then. And we are ready to start substituting in our values and solving for that final velocity. All right, so I've got my displacement subbed in there, my initial velocity subbed in there, and my time subbed in there as well. Now I'm just doing a little bit of algebra to try to get VF by itself on one side of the equation. All right, so I might go through and divide both sides by 5. So 12 divided by 5 is 2.4. That'll cancel out the 5 on the right. And then I've also simplified this down because 0 plus VF is just VF, right? Adding 0 doesn't do anything, so I can kind of ignore that part and take it out because it hasn't substantially changed the value inside the parentheses. So now I've got 2.4 is equal to 1/2 of VF, so then I can just divide both sides by 1/2 or multiply by 2, same thing, right? And I get a final velocity then for my puppy of 4.8 meters per second, right? Got to make sure we got units in there as well, by the way. All right, so since we did a displacement in meters over a time in seconds, we know that the units in there are meters per second. Last thing that I want to do is just make sure that this seems like a reasonable value. So if I think about like looking at a meter stick, which is about a yard, right, if that's easier for you to think about. I'm looking at about 5 meter sticks in a second, which is pretty speedy. But if I'm talking about like a super manic, highly motivated puppy, that seems like a fairly reasonable number. All right, now if I do a little bit of unit conversion here, I can determine that 4.8 meters per second is about equal to 10.7 miles per hour. And if I just Google like top speed of a dog, it says 15 to 20 miles per hour, even faster for some other dogs as well. So this seems like a reasonable number for me to have gotten. So I feel good about all of that. Right? Last thing that I want to do is just walk you through some other key phrases that will give you useful information in a problem. So in this table, I've got different phrases, and I want you with your group to try to figure out what is the meaning of each of these phrases. Like if something says it starts from rest or comes to a stop, what value is that telling you? If it's asking you how fast or how far or how long, what is it that you're solving for? And if you see a measurement in units of meters or meters per second or meters per second squared, what is the significance of that? Take a moment with your group to discuss, and then we'll go over it. All right, so looking at this first one, starts from rest means initial velocity is 0. I started off not moving at all, so initial velocity is 0. Comes to a stop means that we are ending at a velocity of 0, so final velocity would be 0. Now, if a question asks you how fast, that means you are solving for a velocity. That might be initial velocity, that might be final velocity, or it might be an average or constant velocity as well. You'll need to look more at the language of the problem to see what it is, but you do know that it is some sort of velocity or speed that you are solving for. If a question asks you to calculate how far, that corresponds to a displacement, all right, or a distance if we're just dealing with scalar quantities here. And if it's asking how long something takes, we're looking for a time. That's the thing that we are solving for. Now, if we get a measurement in units of meters, meters are a great unit for displacement. So displacement would be the value or the variable that we're attaching to that particular measurement. If you see units of meters per second, that's a velocity. That's how fast something is moving. And lastly, units of meters per second squared, then you know that you are dealing with an acceleration. All right. With that, hopefully you're feeling more prepared to take on some more problems and start using your physics knowledge to analyze the world. Good luck. You got this.